Hi Year 12. So this video is looking at quantiles, which works in with 1404 in our probability, our PDF topic basically for Year 12. And the first thing we want to look at is the median. Now the median, when we were looking at all our data earlier on in our junior school, is the middle. And it's in this topic, it's the value that divides our data or our function in half. So if we've got a median, we've got an area that is equal to a half of our total area. So if you think in a normal PDF, our full area is 1. So the median will cut off at halfway and give an area of equaling to 1/2. So for example, find the median of the continuous probability distribution. So it's told us it's a continuous probability distribution. It's defined as x squared on 21 in the domain 1 to 4. Let's find the median. So we need to start with, work out what our CDF is. I'm going to do that one. So our cumulative distribution. So if we do that, we're going to integrate x squared on 21 between x and 1. Okay, minimum value is 1 and our top value is our x. And because we don't have a top value, okay, we don't know what that x is in terms of the value that is on our domain that will cut off an area of a half. So we have to pop that in as an x. So x cubed on 63 it'll be, because we've added 1 to the index. We're divided by the 3. 3 times 21 is 63. Pop in the x, take away what we get when we pop in the 1, and we're down here. Or you can neaten it up as x cubed minus 1 on 63. So pause that if you need to go back and have a look at that. So to find the median, what we're saying is this value here is going to be equal to 1/2. Here we are up here. I've multiplied both sides by 63 and got x cubed minus 1 is 31.5. Added 1, so x cubed is 32.5, and then I've taken the cubed root, which is 3.2, and that's rounded to 1 decimal place. So the median is 3.2. So that would mean we have got a value, and I'll just quickly give you a sketch. I don't know what my graph looks like exactly, but it probably looks something like this, between 1 and 4. So to get an area that is a half, what we're saying is that would happen at a value of 3.2. So probably, I might move that up a little bit because it's probably more realistic to be up there. And that would get me an area of a half of the total area. And that's our value there. So what it's basically worked out is that the probability of our value being less than 3.2 is a half. Okay, let's have a look at the next one. Quartiles, deciles, and percentiles. Now, quartiles comes from the word quarter, okay, which is 0.25. Deciles comes from the word decade, or groups of 10. So we're looking at 1/10 or 0.1s. And percentiles, well, they're percentages, aren't they? So they're out of 100, or percentaries, and they're 0.01s. And we're probably used to the percentiles more than the other things. We've looked before at quartile 1s and quartile 3s in our box and whisker plots. Okay, so if we're looking at the first quartile, or the first quarter, it's going to be 0.25, or the third one is going to be 0.75. Now we might need to draw some diagrams for each of those. So it says each of these can be found by assigning a decimal to the cutoff, as we did with the median. Okay, so let's find for the first one. A continuous probability distribution is defined as the function is x to the power of 4 on 11,605 in the domain 4 to 9. Find correct to 2 decimal places the last quartile. Okay, I'm going to draw us a picture for that. We actually have a parabolic-y looking function there. Probably something like that, between 4 and 9. And we want to find the last quartile. So we want to find where we've got Q1, Q2, Q3. That value there would give us an area of a half if we cut off at that point there. The last quartile is going to be the value that will give us an area of 0.75. Okay, and the first quartile is going to give us an area of 0.25. So what we want to do here to find the last quartile is let's integrate our curve and find our CDF, the cumulative distribution function. The minimum value is the 4 up until the x, and we're going to find what that x is. What x cuts off at 0.75, the area, is what we want to do. So x to the 5 on, when I add 1 to the power, divide by that power, it's 5 lots of this, so 58,025 between x and 4. Okay, pop in x, take away what we get when we pop in 4, and here's my CDF here. That CDF is going to be equal to 3/4. So we're finding the value of x, which will give us an area of 3/4, or a probability of 3/4. Times by the 58,000, add the 1,024, take the fifth root, and we get 8.5. So what we're saying, if we go back to my graph, is this Q3 here is going to actually be 8.5. So if we work that out, that area under the curve from 8.5 down is going to be 0.75. So the area the other side is 0.25. Okay, so what we would do for the last two, the 8th decile, well, deciles were groups of 1/10. We've got 8/10 here, which is 0.8. So we do exactly the same as what we just did here. Instead of letting it equal to 3/4, I would let it equal to 0.8. So here we are again. Multiply, add, fifth root, and I get 8.6. So if you think of the 8th decile, okay, it's going to have an area of 0.8. So it's going to be slightly more area than our quartile 3. So we're going to get a value that's slightly bigger. So that's 8.6. That one sits in there. And lucky last, the 43rd percentile. So that's 43 out of 100, or 0.43. And that's going to be a lot different. So if we want an area of 0.43, we're going to be way down this end somewhere. I don't know what that's going to be yet. What we do, same as we did the other two questions, is we'd get our CDF and we'd let that equal to 0.43. We'd work out algebraically what our value of x is, and we'd get 7.64. So we're going to be a little bit further down this way, and we'd get an area that's smaller down there. So that is how we would work out those questions. And you're going to need to practice these, okay, to sort of get your head around what's happening with those, and that will work you through 1404.